Hello and welcome back to this video lecture series. Now in this video lecture, we are going to learn the mode of inheritance. As we have learned in the last video lecture that what is the scope of the access specifiers, the private, public and protected. So now we are going to put that logic in a mod form, that in which mod you have inherit the base class. Till now we are generally using the public mod. Right? So here is a table, we are going to use that table. Right? So let's see that what we are going to learn by this table. Let me zoom this. Okay. So now this is the base class access specifiers like A, B and C, private, public and protected. So these symbolize that either your data should be private, protected, or a public. So now here are the mode of inheritance in the derived class. So now currently we have used the public access specifier, and we also learned that in the last video lecture that private only limited to the class in which you have declared. So your private can't be assessed. So I'm going to put a cross over here. Private can't be assessed, fine, irrespective of any mod. Either that should be public, private, and protected. So I'm going to give you just a clue that what this mod specifies. Actually, this mod is defining the behavior of inherited data member or a method, that how it's going to behave in a derived class. Okay. Uh, in a public access specifier, the private can't be accessible. If I'm going to change this public to either private or protected, you can't access the private data member of a base class. Private can't be accessed irrespective of the any mode of inheritance. So that is general rule for the private data. So let me change this more formatted format. Okay, so it's the same table, but it's nicely formatted. Okay, so private data can't be accessible. Fine, it is only accessible in the class in which you have declared those data member or member functions. Now let's see the next, that protected. So now the protected of a base class, you have assessed, look, you have assessed the C, which is protected in a base class, protected in a base class. Similarly, your this B is a public in a base class. So now look, R, C and B is going to be affected in this case or not. How we are going to check that? To check that, I am going to create one more class. Let's create class F. This is the proper format. Fine. So now here I am going to again writing the one method void assess, ACC assess. So now I am going to make this F. Okay, let me close this. Okay, let me compensate the space so that the most of the code would be available on the screen. Okay, void input. Okay, fine. So this is a class F. We use this format to compensate even one more space. Okay, so void assess. So let's do in this manner. Okay, so void assess. Now I'm going to try to. Okay, first I have to make F as the child of a class child. Okay, that would be, let's take public child. So you can see that this is a multi-level inheritance. Okay, so now in this last class, grandchild class, I'm going to assess C. So here I will write C equals to 88 and B equals to 99. Let's again compile this. Okay, so there is a no error. Why there is a no error? Because assess mod is public, fine. So it's a private. So here is a public. So let's start with this. So mod of inheritance is public over here. Let me switch this so that public should be somewhere here. Okay, public then private. So why I switched this? So we have learned this, public and private, even in many previous lectures. So that's why I'm going to consider these one first. Okay, so protected we are going to learn at the last. Private data can't be accessible in a public mode of inheritance. Okay, so now the protected. So look, you can see that public, private, and protected as a mode of inheritance is acting as a filtering mechanism. Fine, it's going to narrow down the scope of a previous class. So you can say that these are implemented for the security reason. You are implementing a more security. So public is very lenient one. Fine, you can consider it as a lenient mod. So protected remains protected. Okay, so it's a protected. Public remains public. Right? So there is a no effect in the base class data member that how they're going to behave in the inherited class. So here C is a protected in the base and it's remain protected even in a class this child. And same with the B is initially public, so again it's remain a public. Fine. So you can see that that is the reason that why we are able to possess the C and B even in a grand child class. Okay, so now I'm going to change on this keyword from public to private. Now let's see that scenario that what this is going to affect in our logic. So here I narrow down, it means private. I put a more restricted security while inheriting the data. So now A, B, C, these three are available in the base class, and this is a child class, and its parent class is a base. So private can't be inherited, we already learned. Now, public and protected, you can assess that, fine. But here mod is private, it means C is protected in the base class, but here there is a one more add-on that now C is acting as private in child class. Right? So here you can assess the C in a child class, but here the child class doesn't have access, doesn't allow some another derived class to have access to the C. So C is acting as a private over here, just like A is acting private in the base class. So this is the main concept. I'm repeating that thing again. Look, here I wrote a private. So it means whatever the data, it's you can say it's a narrow filter. So private is the narrowest filter, fine, public is a broader filter, protected is a in between. So here I put a narrowed filter. Even the lenient access would be now narrowed down. So it means public is going to filter to the private, resulting in a private. So B is even also acting as C, even B. Both are acting as a private in this class. So now you can see here C and B are the private. So now if you are going to try to assess the C and B from a F class, which is a grandchild of a base and a child of a child class. Fine. So now if I'm going to execute this, so I will have an error at this line. It says that C and B is inaccessible because these are acting as a private in this class. Fine. So you can't access the private data member, just like we have learned that A is not accessible within the child class. So let's compile this. Okay, so protected. So it's that base is a protected, and it should be private over here. In context, okay, this one within the context, this one. So here we have a error that these are not supposed to be used over here. So even within this context, so even C here, C and B, the compiler doesn't allow to access this. So this was about the private. So it means the protected become a private, and even public become a private. Fine. So I hope this is clear. If you have any doubt, you can ask any query in a comment section. So let's proceed to the protected one. So instead of a private, I'm going to replace this private with a protected. So now let's see. So what do you think? Can you guess that how this protected is going to behave over here? How public is going to access over here? So look, I already told you that a filtering mechanism. So protected is just a lenient filter. Fine. So now private, you can't access the private. Protected, putting a filter of a protected remains a protected. Fine. But here public is a broader thing. Fine. And protected is a little bit stricter. So it is going to convert that public to the protected one. Fine. Okay. So now protected C. So here now these are the protected, means these two, even that a public one is now acting as a protected over here. So protected means it is going to access within the class, fine, within the class, and okay. So I have to raise this comment. No need for this because I have changed the mode. So now the scenario, whole scenario is different now. So this is the protected. So in a protected, these two are acting as a protected. So it can be accessible within this class and its derivative. So now we don't have error at this line number 16. Okay, so 0 error, 0 warning. So now let's see what's the difference between the private, public we have used and protected we have used. In both cases, we doesn't have any error. So now let's create the object of a grandchild class. So now from this we would our concept would be more clear. So now obj, it's f object obj dot. Now you can see only b is available. So where is the b? Okay, so b is a public, but now b is here protected. So syntactically, it's not intelligent help is not giving us an error. So that is going to provide B. So now let's execute this program. So I expect error from line number 22. Okay, so in context with line number 22. Fine. So why is it so? Because B is no longer public in a class F. Fine. So it's a protected. So now whole scenario will change. Okay, let me close this. So now B was initially public in a parent class. In a child class, B is a protected. In a grandchild class, so as it is a protected, you can access this, but you can't access outside this class. From main, you can't access that. So now let's that is even with a child. Okay, even in a child, your B is protected. So even if I'm going to write child over here, so in context, same, fine. So now if I'm going to access the same thing with a base class, so in that case, we don't face any error because this B in a base class is acting as a public. Public you can access anywhere from the class. Protected is within the class specified and its derivative. Private is only within the class, and we have learned that how the mod is affecting your logic or the behavior of the data member or methods in you know the derived class. Keep tuned to my video lectures. Subscribe to my YouTube channel so that you can have update videos. And thanks for watching this video.